Hi,
Well, hi, Christina. How are you?
I'm good. How are you?
Oh, good. How is your chemistry class going?
It's good. It started on Tuesday and Thursday. So there was nothing like big this week. We just had a lab. That's about it. But this week is our first exam. So I'm like kind of nervous, but the professor's really nice and
Oh, good.
I think I'll be okay. Yeah.
Okay, good. So, how did the chapter 8 go for you? I think it
It,
didn't go too bad, right?
yeah, I got like a 84%, which is like
Okay.
okay. Yeah.
Okay.
Yeah.
Yeah. Then let's see. We can start on chapter 9. Then, did you have any questions that you wanted to ask?
No, the last chapter was pretty simple, so I
Okay.
think I'm okay with it.
Yeah, and chapter 9 is really just there just a couple of topics where they're either like just applications or they're topics where they probably just wouldn't fit in normally in the class, so they just saved them for the end. So I
Yeah.
have like a couple of examples here. So, and there's a whole bunch of other stuff on the page, but that's okay. I just go as we usually do. And then in this chapter, there isn't really, even on this first 9A quiz, there's only 9 questions. So they might take a little bit longer if you're not used to them, but I don't think that there are things where you can't do them. So number 1 here then is, all right, so a pipe leans against a building. So I would normally just draw a diagram. So it says that the angle between the ground and the pipe is 75 degrees. So now I will tell you that, like depending on how you look at the world, like if you draw this diagram a different way than me or even the book, that it would be fine. But this is, say, the ground right here. I'll draw a little bit of grass or something here, and then the building is right here. So that's the building, and then the pipe is leaning against the building. So if it's just like a pipe that is leaning against the building, but the angle between the ground and the pipe is 75 degrees, then that is the 75 degrees. So that's the angle between the ground and the pipe. That will be 90 degrees, assuming that the building isn't leaning or anything like that. Then if the bottom, so that was actually the 75 degrees. If the bottom of the pipe is actually positioned 8.5 feet from the building, so this is the bottom of the pipe right there, and they said that it was 8.5 feet from the building like that. So then what is the pipe's length? Sorry, I don't. Okay, so what is the pipe's length? So they want you to find the length of the pipe. So find the length of the pipe. So what is going on here is actually the same thing that has been happening in a previous chapter, because they're just really looking at this triangle right there and saying that this is 8.5 feet and that this is 75 degrees. And then this is X because you want to know the missing length of the pipe. So then from here, what I would say is that if you think of this as the 75 degrees being the theta, and this is the adjacent to theta side, this one is opposite from theta, and this one is the hypotenuse, then if you want to, well, essentially, if you remember back, if you know the adjacent side and want to find the hypotenuse, then you just say that where is it? Oh, cosine of theta is adjacent over hypotenuse. So cosine of 75 degrees is 8.5 over that X, and then cross multiply. So cosine of 75 degrees times X is 8.5, or X is 8.5 divided by cosine of 75 degrees. And then you can give a decimal to two places if you want. So if I do this in degree mode, so I have 8.5 divided by cosine of 75 degrees. So that is 32.8414789. But to two decimal places, it's 32.84 feet. So do you have any questions about that, Christina?
No, it's simple.
Okay, yeah, I think like if, I will say that if you look in the book or somewhere else, they might actually draw the building over there, but then that would be the 75 degrees, and then that would be the 8.5 feet, and that would be your X, but it doesn't really matter if you move the triangle in the opposite direction, it would still be the same
Yeah.
thing.
Yeah, I'm not gonna lie, the book is like pretty confusing on explaining. So I just really just follow your steps and like when you get an answer wrong on the practice test, like I look at that as well.
Yeah,
So
it does help. It really, like both of those things help. Yeah, sometimes a book does weird things. I'll
yeah.
say that. Where number two go? All right, number two. So this is a common one where like two triangles are involved. So a survey team is trying to estimate the height of a mountain above a level plane. So now I will say that the the plane right here is down here. So this would be the level plane down here where the surveyor team is at. And then the mountain would be sort of up here like that, something like that. And I was just in the mountains. So it's hard to make some sort of guess at that. So this is gonna be whatever it is, that's going to be the height of the mountain. So it's not necessarily, the mountain itself isn't actually like straight up, but you are actually taking the measurement straight up. So that's actually the like one bit of a distinction from the last problem. But then from one point on the plane, they observed that the angle of elevation to the top of the mountain is 29 degrees. So if you're right here, then the angle of elevation would actually be that right there. So 29 degrees. So this is wherever you have something like this, and then the, and again, it doesn't really matter how you draw it. If you draw it like this, that would be an angle of elevation because it's going like up from that point. But then if it is, say, going down, then they call it an angle of like depression usually, because you're like pressing it down. So it doesn't really matter. Like if you are saying like you're going up that way, then it's angle of elevation that direction again. And then if it's going, say, down that way, then it's angle of depression again. So I feel like people get those sort of things like confused, but this is actually just like going up from where you started. So it's 29 degrees. And then if they move to a point 1,400 feet closer to the mountain along the plain, they find that the angle of elevation 31 degrees. So you don't know how far this is total, but so the total distance, we actually, right, the total distance we don't know, but we do know though that if, so if I were to actually draw this again, and this is, the mountain sort of right here, and that from that point they actually went, so this is the height, that they actually went in 1,400 feet. So this is 1,400 feet. Then that angle of the elevation was actually 31 degrees. So 31 degrees like that. So what I guess I'm saying is that this right here, this distance is still unknown. So unknowns distance still. And then you have the, right, you have the total distance that you don't know what they are. But the reason why this gets a little bit tricky is because you have this triangle right here, and you have this triangle right here. But usually what happens is that you'll see them drawn on top of each other. So you'll see them drawn sort of like this, that they'll have this, and then they'll have this, and then they'll say that this is 31, that's 29, and this right here is 1,400, and that this is X over here, and that they'll just draw all in one graph or one diagram. And that's where I feel like it can be a little bit, tricky to interpret what what this is saying here. So then what I will say then is if you actually, well, this is what I think the harder part is if you say that this unknown distance here might be X, then you know that this total distance is equal to X plus 1400. So it's those two added together. And then if you use this triangle up here, then you know that this is the adjacent side. So this is adjacent, this is opposite, and this is the hypotenuse. This is adjacent, this is opposite, and this is the hypotenuse. So if I use tangent of the 29 degrees, that is opposite over adjacent. So here, if I use tangent of 31 degrees, that's opposite over adjacent. But in this triangle, the opposite side is the height of the mountain, which you can really just call it whatever letter you want, maybe H for height. So that's the tangent of 29 degrees is H over X plus 1400. And then here we have tangent of 31 degrees is H over just the X. So then what you do is you take these two equations and then you think of it more like a system of equations. So if you have tangent of 29 degrees is H over X plus 1400, then since you don't have to give the exact answer, then you could change it to decimals a little bit sooner. So 0.55430905515 is H over X plus 1400. And then let's see, if I cross multiply here, I have 0.55430905515 times X plus 1400 is equal to H. And then let's see, if I distribute that right here, I have 0.55430905515 X, and if I multiply that by 1400, I get 776.032672 equals H. So that's H. And then for the other equation, the tangent of 31 degrees is H over X. Then tangent 31 degrees is the 0.600860619. So then I can go ahead and just multiply by X. So 0.600860619 X is equal to H. And then really it's up to you what you want to do at this point. I will say that if you try to solve this for, well, I mean, I guess you really need to know what X is, but since it's just a system of equations where it's that H is 0.55430905515 X plus 776.032672, and then h is equal to the 0.600860619 x, then since they're both equal to h, you could set these equal to each other to figure out what x is. So that would give you 0.55430900515 x plus 776.0326672 is equal to 0.600860619 x, and then subtract this right here from each side to get x on one side by itself. So if I do that, then it's really just that number minus that number right there. So I have 776.0326672 is equal to 0.04655155675 x, and then divide by that number. So you take that 776 number, divide it by that number, and then you get a, I don't think that's, yeah, okay. So that would be x is equal to 16670.38757. So then because they wanted the height was h is equal to 0.55430900515 x plus 776.0326672. That needs to be substituted in for x. And if you do that, and this is where I feel like, you don't want to have to recopy those numbers too many times, but you get 10016.57939, or to, let's see, I think they asked for probably like 2 decimal places like usual. So 10016.58 feet tall. So do you have any questions, Christina, or anything like that seems like tricky to you about this?
No, it's like a good amount of steps. Like it's pretty simple. They're just larger numbers. That's pretty much it.
Yeah, I think it's like I would say that you could just write it in terms of tangent all along, but I feel like it, like you might lose track of what it is if you do that. So I just want you to be careful is all. So that's why I just figured it might be easier to write that out. Okay.
Yeah.
Let's try the next one then. So question 3 actually goes and it moves into the other topic for the section. Excuse me. So then let's see here. It says solve the triangle. So whenever they're talking about solving the triangle, I want you to just remember that in this section, they're not going to be really any necessarily right angles anymore. So if you look at number 3, all right, so this is what I would generally do is I would just draw like a random triangle because you don't know what it actually looks like. And if you have, say, alpha and then beta, and then they'll use I think they use just, oh yeah, they'll use gamma. Then A will be across from alpha, and B will be across from beta, and C will be across from gamma. And so there are actually two properties, and one of them is called the law of sines. And so the law of sines actually is fairly reasonable, but it is now, it will actually depend on who you ask how they might actually, yeah, how they might actually write this, but you might see it as sine of alpha over A. I don't know, sorry, I don't know why it's making this, why is making this noise over here? Okay, equals the sine of beta over B equals sine of gamma over C, or you might see the reciprocals, A over sine of alpha equal B over sine of beta equals C over sine of gamma. That is fine. Either one of those is actually okay there. And so I don't know why my computer keeps on dinging when I didn't actually like do anything to it. I'm gonna try to get this to stop because it, okay. So then you actually need to use, now I have this handout actually in the, like in the Google Drive folder. If you like go there and to the link on Canvas, and then it will be in the one that says trigonometry resources, and then law of sines. So this is what I was saying, that the book uses the reciprocals of the law of sines, but then you use the law of sines when you know the length of two sides and an angle that of the measure of an angle that is opposite of a known side, or the measures of two angles and the length of any side, and then the law of cosines when you have one of these two cases over here. So this all goes back to, if you look here, so you see like the check mark, so you have the side and then a side and then an angle known. So they would call this case the side angle. So SSA, or right here you have a side and then an angle and then an angle known, or right here a side and then this angle and this angle known. So this is actually the, they would say what, side angle angle, or angle side angle. Have you seen those abbreviations before, Christina?
No, this is my first time like seeing.
Okay, well, no, that's fine. Yeah, so like sometimes like if people have taken like geometry, then they use like side angle angle, or angle side angle, or side angle. But if you haven't seen that, that's not a problem at all, honestly. It's just I wanted to point out what the different scenarios are. And if for some reason you are given, say, the side, then the angle between them and a side, then that would be side, angle, side, or all three sides, but none of the angles, side, side, side. So then the reason why this is important is because specifically if you are dealing with this law of sines here, then where is it? Yeah, this is the, okay, so out of these four, this is actually the case that's the hardest one. Because on the second page of the file, it will talk about an ambiguous case. And in that ambiguous case, it must be a side, side, angle, triangle. Now, the issue with that is that you might have, say, no answer, right? Like no triangle, or you might have actually just one answer, or you might actually have two answers, and that's where this is a, the harder one. But I think the only hard part about this is most of the time, no one actually like tells you how to tell if there isn't an answer or if there might be more than one answer. And so that's why I'm giving you this extra handout, but I will like go through an example like that. But this is the case where, right, side, side angle, you could have no answer or one triangle or triangle or two triangles. So I just want you to notice that is happening here so that you don't actually yeah have any mistakes with that. So now, all right, now let me tell you the law of cosines real quickly, because even on the handout that I have here, they only give you one of them. So if you have the law of cosines, then that would be if you have, so one of them, and again, they might actually give it to you in multiple different ways, but if it is, say, a squared, so if you want to find a, then it's a squared of b squared plus c squared minus 2bc cosine of a. But if you want to find b, then it b squared is a squared plus c squared minus 2ac cosine of b. And then if you want to find c, c squared is a squared plus b squared minus 2 a b cosine of c. So the reason why they only give you one sometimes is that you could relabel all of these and it would end up being the same result, but the pattern I think is pretty easy. Like whatever the side is over here, that's the angle that's across it over there. So do you have any questions, Christina? Okay, then in number 3, then if you look at this, so we'll try to do one that says solve the triangle with the B is equal to 50.3, C is equal to 61.6 and alpha is 76 degrees. So what do we know? We know a side, an angle, and a side. So we know side, angle, and then a side. So we know C is 61.6, alpha is 76, and we know B is 50.3. So since this is side, angle, side, then that means we are going to use a law of cosines. So if you have this one or this one, so yeah, use with side, angle, side, and side, side, side. And this one use with the side, 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 which could be ambiguous, or with side, angle, angle, or angle, side, angle. So then this actually means that you're going to use the law of uh, cosine. So then use the law of cosines. So then if you know the C is 61.6, alpha is 76, and B is 50.3, then the one that you have the correct information for would be this one up here. So A squared is B squared plus C squared minus 2BC cosine of A. And then if you just substitute in the information, then you have A squared is, let's see, 50.3 squared plus 61.6 squared minus 2 times 50.3 times 61.6 cosine of that 76. And you can write alpha, beta, gamma instead of A, B, C up there if you want. That's fine too. But then if you do that, then you have, all right, so let's see. So we have 50.3 squared plus 61.6 squared minus 2 times 50.3 times 61.6 times cosine of 76 degrees. So then if you take the square root of that, then that will be your A. So A squared is 4825.46969. A is the square root of 4825.46969, which is about 69.465600077. So to two decimal places, it is then, yeah, A is about 69.47. So that is the first thing. And then you still need to find out the beta and the gamma. But do you have any questions, Christina? Okay, let's see. Where is that? So, okay, so then let's just see here. So we have, I'm just gonna draw this again. So we have that alpha was 76, and then A was 69.465600077, and then the C was 61.6, the B was 50.3, And then we need to find beta and we need to find gamma still. So, all right. So I just drew that all over again. Now, even though I said that A was approximately 69.47, until I actually find the final answers, I still want to use the answer without the rounding in it. So if I go for finding another angle, then it doesn't, at this point, it really doesn't matter which one that you want to use. So let's say that you try to find the gamma next. So then we're still using the law of cosines to do this. And then the one with the gamma in it would be c squared is a squared plus b squared minus 2ab cosine of gamma. So we know c is 61.6, and then a is the 69.465600077 squared, and then b is 50.3, so 50.3 squared minus 2 times the 69.465600077 times the 50.3, and then cosine of gamma, which I still don't know what gamma is. And then I can go and simplify this. So if I take that number squared plus the 50.3, here, I'll do that. That number squared plus the 50.3 squared. Then that's, well, and if I put 61.6 squared, I have 3794.56 is equal to 7355.55969, and then minus, and I'll do the 2 times that 69.46 number times 50.3, so 6988.239437 cosine of gamma. Then I'll subtract the 7,355 number from the other side. So that minus that number right there, that's negative 3560.99969 will be negative 6988.239437 cosine of gamma. Then I'll divide by that. So divide by that. So I end up with 0.509570366 is cosine of gamma. And then gamma is actually just the cosine inverse of that number. So cosine inverse of 0.509573, 03606 is gamma. And then as long as you're in degree mode, you should get the 59.36478.408 is equal to gamma in degrees. And then if you want from there, you can actually use the law of cosine to find beta, or since you know that you still just need to find the beta, then you can either use the law of cosines and say that the b squared equals a squared plus c squared minus 2ac cosine of beta, or you can just say that the alpha plus beta plus gamma is 180 degrees. So then beta is 180 degrees minus alpha minus gamma. So this way will be longer, of course, because it's 50.3 squared equals that 69.465 60077 squared plus 61.6 squared minus 2 times that number right there. Let's see, times that number right there for C cosine of beta. Or again, you could just easily say beta is 180 degrees minus the 76 degrees minus the 59.3647848 degrees, and then be done with it from there. So I don't really feel like it's that bad, but it's just putting this all together, because this way 44.63521592, or to the 2 decimal places 44.64 degrees, and this is 59.36 degrees. So do you have any questions, Christina?
No, I think it's okay.
Yeah, like I said, like the hardest part will be just probably remembering like which of the two properties you need to use, like law of sines or law of cosines, and then go from there. So let's see where's another one here? You still need to write something down, just let me know, but I'm just moving it because they're flying around
No, I'm almost there. The writing.
Oh, okay, you're done. Okay. Yeah, like I just moving it because it's flying around the room. So, all right. So this one is number 4. So it says solve the triangle with beta is 44 degrees, alpha is 59 degrees, and A is 32.37. So if I draw a triangle just like before, and again, I really don't know what it's like in advance, so I'm just going to draw one just for the sake of like labeling the alpha, beta, gamma, A, B, C. But the beta is 44 degrees, and the alpha is 59 degrees, and the A is 32.37 degrees. So in this particular problem, I have a side that's known, and then I have two angles that are known. So this is the angle side, or AAS, or you could say it's side angle. It doesn't really matter. Some people call it SAA. It doesn't really matter to me which order that you write these in, because it's just yeah, it's SAA or AAS, but that's just the way that it is there. So then, all right, if you have that case right there, then that means that you need to use the law of sines. So that's really all that this is here for, is to tell you which one to use. So since this is a SAA triangle, then use the law of sines. So that's just the sine of alpha over A equals sine of beta over B equals sine of gamma over C. Now, the first thing I probably would do though is find gamma, because gamma is just, so if you want to find gamma, gamma is equal to 180 degrees minus beta minus alpha. So 180 degrees minus 59 degrees minus 44 degrees. So that will be 77 degrees. So this is just 77. And then from there, so that's 77 degrees. Then you know that if you want to find the missing B, that you can use sine of alpha over A is actually sine of beta over B. And then if you want to find the C, you can use sine of gamma over C is equal to the was it the sine? Yeah, actually, sine of alpha over A. Now, by the way, okay, so I guess I do want to say something else. That if you are trying to find uh let me see how I want to say this, because if you actually want to find the, yeah, okay, so I guess I would say that now that I see it, there is actually a reason why somebody might write these in two different ways. And I didn't think to say this before, but if you write it with the sign of alphas on the top, sign of beta, sign of gamma on the top, then this is the way that you would be easier if the angles are missing. And then this is the one that would be easier if the sides are missing. So I probably, because in number 4, the side B is missing, then I probably would use the reciprocal instead. But again, it doesn't really matter. It's just in terms of which one will be quicker, it will be a little bit quicker if you know, if you're trying to find the missing side, that you put the side in the numerator rather than in the denominator. But otherwise, it really doesn't matter. So in this particular case, if you have the A and it's 32.37 over sine of alpha, which is 59 degrees, and then you have the B, which you're trying to find, over the sine of beta, which is sine of 44 degrees, then you can actually go ahead and it's really up to you. But some people, I would say, like, are okay with just multiplying by sine of 44. Some people want to actually do the calculations, and either way is fine. So you do this at 37.76392307, and then sine of 44 is 0.694. So B over 0.6946583,705. And then you can multiply the 37.76 number times the 0.69 number. And if you do that, then you have B is equal to 26.23302526, or about 26.23 to 2 decimal places. So I don't think that's too bad, but I think that you just have to keep track of those numbers. But if you do the next part and want to find C, then you have C over sine of gamma, which is 77. And then A was the 32.37 over the sine of the alpha, which is 59 degrees. So we already know that number right here. So that was the 37.76 number. But if you do the sine of 77, then you get C over 0.97437000648 is equal to the 37.76392307. And then multiply those two numbers together. So if you do that, then you get that C is about 36.79603617, or to 2 decimal places, 36.80. Oopsie. So do you have any questions, Christine, or anything that you want to ask about with the law of sines? Because one of these is, oh yeah, go ahead.
No, it's mostly just like formulas. It's just keeping track of the bigger numbers. But I think it's gonna be easy.
Yeah, I will say that there are okay, yeah, I want so what since there's not that many questions in this chapter, I forgot that there is one more topic. So I do want to actually on Wednesday, like talk about the law of sines with the one case that's the difficult one. But because that's the one I think that it like 1 through 4 are easy because they didn't have that difficult case in them. But I wanted to at least say one other thing, and it was about the area of the the area of the triangle. So if you actually I wonder where, I don't actually know why I can't find what I'm looking for, because this is actually very odd, because hold on, because it has to do with the the area of the triangle, in that there are there's multiple ways to find it. So I'm just gonna tell you the formulas, and then we can do the examples on Wednesday. But okay, so area of a triangle Okay, so area of a triangle. So I feel like this is actually the part where it gets people every time, that there is maybe like more than one way to like find the area of the triangle. And so they where is it? I don't actually know why. Okay. Yeah. So of course there is the area is 1/2 base times height formula that everyone everyone knows. But then there are other ways. So one of the ways is actually no one. I'm looking for like the diagram of it, but I'll just draw it for you. All right, so that's method one, the original way that everyone always learns. But the other one might be that if you have a triangle that looks like this, and you have the alpha, and then the beta, and then the gamma, and the A, and the B, and the C, and then this is the height of the triangle, the H. Then if you know uh, two sides and an angle, meaning that you have angle, what, two side, side angle side. So if you know two sides and an angle, then meaning side angle side, then the area is going to be 1/2, and then the AB sine of gamma, or area is equal to 1/2 BC sine of alpha, or the area is 1/2 and then AC sine of beta. So it's really not too bad, but you just have to pay attention like before to what information was given. Now, if for some reason, then so if for some reason, then you know one side in all angles, which is something that could happen, then if you know one side and all angles, then what you could actually do is say that the area, this one would end up being, so then it would be on this side. So this side would end up being the A squared, and then sine of beta, and then sine of gamma over 2 sine of alpha. And then this one would be the B squared sine of alpha sine of gamma over 2 sine of beta. And this one would be C squared sine of alpha sine of beta over 2 sine of gamma. So I can't say that that would necessarily happen a lot, but if it did happen, then you could use that formula. But then the third way is actually something called Huron's formula. So, and there actually are other things that I guess could be helpful. So, but I'll talk about this third one. And so that's actually Huron's formula. So where is it? I can't spell the guy's name. So yeah, Huron's formula. So that one might happen if you only know the 3 side lengths. So that, and that specifically, right? If you know, yeah, 3 side length, but no angles. So then it it's really one of these things where if you look at it and you have the A and the B and the C here, so A, B, C, then the semi perimeter or S will be equal to the A plus B plus C over 2. And so then the area of the triangle will be the square root of S times S minus A times S minus B times S minus C. Now, I realize like that is actually a little bit to remember. So if you want to do this without using the semi-perimeter, so or right, or without the using the S, then you have that the area is equal to 1/4 times the square root of A plus B plus C, A plus B minus C, A plus the oh I sorry, I can't read my own handwriting. So because I wrote it out before, so that it's yeah, A plus C minus B. Yeah, and then A B plus C minus A. Yeah, I think that's I just want to make sure A and B, yeah. Yeah, I thought that I for some reason had put a plus somewhere and it wasn't. No, but that's right. So I I don't know if you really need to do it that way, but if you don't remember what S is, then you might want to. But otherwise, it's not that big of a deal. The only other thing I might say is that uh, yeah, okay. So I'm only going to say like these other things because they could be useful in calculus because I've seen them come up in really odd like situations, but these are like special cases. So if the if you have a right triangle in a right triangle, then it doesn't really matter what the A and the B and the C are, because because it's a right triangle, that would automatically be the base and that would be the height. So then the area is actually just 1/2 and then A times B. So that's why that's generally like the area for a triangle that people are told, because most triangles are right triangles. And then special case number 2 is when you have an equal lateral triangle. So in equilateral triangles, then that would be like if all of the sides are the same. So that would be like S, like all 3 side lengths equal, then again, I'm only saying this because I've seen it come up in calculus and I feel like it could be useful to you. Then the area is just the square root of 3/4 times that length of the side squared. So that's actually something where you could prove it, but you don't need to if you remember or at least have an idea of what that there, or at least there is a special formula for equilateral triangles so that you can look it up. And then if you have an isosceles triangle, then those are ones where 2 of the lengths are equal. So length of 2 sides are equal. So that would be something like if you have, right, this one is, say, like if this one's like A, and then that one B. So these 2 sides are the same length, and then these 2 angles are the same. Of course, these would be like equal angular, or all 3 sides and all 3 angles equal. But in an isosceles triangle, the area is 1/4 and then times the base and then the square root of 4 times A squared minus B squared. I don't think that people use that formula too often, but I have seen the one for the equilateral triangle used more often as a special case than the isosceles triangle, though. Although, like I said, you really don't need to know it is special, but if you do, it could be helpful. So do you have any questions, Christina?
No, I don't. Yeah.
Okay, then
It seems pretty simple. It's just formulas, but I just think I just have to practice on it a little bit. I think I'll be okay.
yeah, I think so too. I will say that if you want to like practice, or if you just want to do like 1 through 4 before Wednesday, because I know you said you have your chemistry test this week too. So that's actually, in my opinion, that's more important to study for right now anyway. So like you can take your time on these, because it probably will take time to get used to them anyway. But other than that, yeah, just if you want to get started at them, get started, and then on Wednesday we can finish up some more examples.
Yeah, I think what I'm gonna do is I'm just gonna do these today and tomorrow. Like I'll work on it, and then Wednesday we have another Zoom, and then I'll study for chemistry in between. So I think
All right. All right. Sounds good. I'll see you on Wednesday, Christina.
I'll see you.
All right. Have a nice afternoon. Bye.
Bye.